AP Chemistry, Unit 6.3, Heat Transfer and Thermal Equilibrium. I need you to recall that particles with a higher temperature have a greater kinetic energy than particles at a lower temperature. Since temperature is a measure of the average kinetic energy of the particles in a sample. At any given temperature, particles will have a range of kinetic energy and a range of speed, but they will all share the same average kinetic energy and the same average speed. So we're going to look at this graph representation here, where we have samples at two different temperatures. Our blue line is going to represent the sample at a lower temperature, whereas our pink line is going to represent our sample at a higher temperature. The y-axis is going to be the fraction of particles with a particular kinetic energy, and then our x-axis is representing the actual kinetic energy. As you see, our sample with a higher temperature, our average kinetic energy is going to be higher than the sample of lower temperature. But you will see also that just because our average kinetic energy is higher for our higher temperature sample does not mean that the sample at a lower temperature does not have any particles that do have that particular kinetic energy. So that's an important distinction. Our average is just that, an average. It doesn't mean that we don't have any particles that have a lower kinetic energy than the average or a higher kinetic energy than the average. Different substances at the same temperature are going to have the same kinetic energy, but differences in substance masses means that their average speeds will be different. So just because we have a sample of gas that is all at 25 degrees Celsius doesn't mean that each of those particles within that gas mixture are going to be moving at the same speed. If we have a gas molecule that is going to be substantially heavier, then it is going to be moving substantially slower than one that is much lighter. So helium, for instance, is going to be able to move much faster at 25 degrees Celsius than argon would be able to, even though they are both gases and they are both at 25 degrees Celsius. So it's important to note that the temperature means that we have the same average kinetic energy. It does not mean that we have the same average speed in between compounds. Within the same compound, same average speed. In between different compounds, different average speeds. So heat transfer is going to be when a hotter and colder substances, particles, are going to collide, and my energy is going to be transferred in between them. This is going to result in the particles that were initially a higher temperature, a higher kinetic energy, losing some of that energy, and the colder particles therefore increasing their amount of energy and therefore increasing their temperature. If the mixing of those two substances results in both substances ending up having the same temperature, we call that instance thermal equilibrium. Okay, so once the mixing of two substances has resulted in a single constant temperature, we have reached what is known as thermal equilibrium. It is very important to remember that heat is always going to be transferred from the hotter substance to the colder one, not the opposite way. So the colder one is intaking the excess energy from the hotter substance. And then also that when substances have reached thermal equilibrium, they are going to have the same average kinetic energy throughout the sample.